plus 2 sine phi a, right? So from here we can easily give the simplification. Here this is 2 cos phi a, here all there is 2 cos phi a. If I take common 2 cos phi a, then I will get cos 2a plus 1 in the bracket. From here this is cos 2a, from here that is 1, so cos 2a plus 1. And for the denominator side, if I take 2 sine phi a common, then I will get here cos 2a plus, from here that is 1, so this will be cancelled, 2 will be cancelled, cos phi a upon sine phi a, that is cot phi a. So this is our right hand side, what we need to prove. Here you can see that we need to prove that this one is equal to cot phi a. So in the end we got that this one is equal to cot phi a, that is our right hand side. So in this way we have solved our question number second of question 4b. So let us move to the question number third of 4b, in which we need to prove that third question, prove that sine 10 degree into sine 30 degree into sine 50 degree into sine 70 degree, that is equal to 1/16. I want to tell you that here also we need to use the same formula, that first of all here for sine 30 we will put 1/2, right? So left hand side that is equal to sine 30, that is 1/2, so 1/2 into sine 10 sine 50 into sine 70. So just we need to prove that this one is equal to 1/8. If I get 1/8 here, so 1/8 into 1/2 will be 1/16. And here if we put sine 70 as it is here, then we will get 1/2 sine 70 into sine 10 into sine 50. Now as we know, if I multiply by 2 and divide by 2, then I will get minus, here I will get 1/4, then sine 70 to sine 10 into sine 50. Okay, so this is 2ss. We all know that c minus c, that is minus 2ss. Okay, so if I put here minus and here minus, then I will get minus 1/4 sine 70, this is c minus c. Okay, so using this formula, first of all for here and second for here, we can easily prove this one is equal to 1/8. So this is for the homework of students. Here you need to put the formula, this is c minus c, right? This is c, that is cos minus cos formula. Use this formula here, then use for this one and for the second part, right? So you can easily prove the statement for the trigonometry, because we have already used twice this formula in this question paper. So this is for the check yourself again, so prove yourself this statement, right? This is the end of trigonometry side. Let us now move to the fifth question, and fifth question is from the vector side. Okay, for the question 5th A, the first question is if A is equal to, if A bar is equal to 3 minus 1 minus 4, B bar is equal to minus 2 4 minus 3, and C bar is equal to -1, 2, -1. Then find the direction cosines of 3a minus 2b plus 4c. So here we will get 3a, 2b and 4c first. So from here I'll get 3a is equal to, here a is equal to 3 minus 1 minus 4. So 3a, that is equal to 9 minus 3, and 4 into 3, that is equal to minus 12. 3a, we need 2b. So here 2b is equal to minus 4. 4 into 2, that is 8. Minus 3 into 2, that is equal to minus 6. And we need 4c here. So this is 4c, that is equal to minus 4, 8 minus 4. I have just multiplied with the scalar 4 with all these coordinates of vector c. So 4 into minus 1, that is minus 4. 4 into 2, that is 8. 4 into minus 1, that is minus 4. So here we need 3a minus 2b plus 4c. 3a minus 2b plus 4c, that is equal to 9 minus 3 minus 12 minus minus 4, 8 minus 6 plus minus 4, 8 minus 4. This is 3a minus 2b plus 4c, and we all know that how to add and subtract vectors. So here, from here we will get that 3a minus 2b plus 4c, that is equal to 9 minus 3 and minus 10. This is the answer of 3a minus 2b plus 4c. If I tell this one is equal to x, this is vector x, then from here modulo of x, this one is equal to say x1, x2 and x3, right? Then modulo of x is equal to in root 9 square, that is 81, plus minus 3 square, that is 9, and minus 10 square, that is equal to 100. This is equal to in root 190, right? So this is modulo of x, right? So we have 3a minus 2b plus 4c, that is x, that is 9 minus 3 minus 10, and modulo of x, that is root of 190. Okay, so now we all know that direction cosines LMN is given by directions cosines. L is equal to x1 upon mod x, m is equal to x2 by mod x, and n is equal to x3 by mod x, right? So we have x1 is equal to 9, so this one will 9 upon root 190, because mod of x, that is 190. M, that is equal to x2, that is minus 3 upon root of 190, and the same way n, that is equal to x3, that is x3 is equal to minus 10, so minus 10 upon root of 190. So these are the direction cosines for the given questions, right? Given vectors. So this is the solution of, this is how to find the directions cosines for the given vector x. First of all, we have find x, that is 3a minus 2b plus 4c. Okay, and then say x is equal to 3a minus 2b plus 4c, that is 9 minus 3 minus 10, that is x1, x2, x3, by modulus x, that is equal to root 190. So directions cosines will be L is equal to x1 upon mod x, m is equal to x2 upon mod x, and n is equal to x3 upon mod x. So this is the answer of direction cosines. Let us quickly move to the second question. That is, the second question is here given that if a bar is equal to 2i minus j and b bar is equal to I plus 3j minus 2k, then find a plus b, a bar plus b bar cross a bar minus b bar and the modulus of that one. So here we need to find mod of a bar plus b bar cross a bar minus b bar. So first of all we need to find a bar plus b bar and a bar minus b bar. So here a bar is equal to, from here it is 2 coefficient of j, that is minus 1, and here coefficient of k is equal to 0. So that is 2 minus 1 0, and for the b bar that is equal to 1 coefficient of I 3 and minus 2. This is a bar b bar. So that is easily we get a bar plus b bar. So a bar plus b bar, that is 2 plus 1, that is 3, minus 1 plus 3, that is 2, and 0 minus 2, that is minus 2. So a bar plus b bar is equal to 3, 2 minus 2, and a bar minus b bar, that is 2 minus 1, that is 1, minus 1 minus 3, that is minus 4, 0 minus minus plus 2, that is 2. So 1 minus 4 2. We want to find a bar plus b bar cross a bar minus b bar. So here we will get from here a bar plus b bar cross a bar minus b bar is given by I, j, k elements of a bar plus b bar, that is 3, 2, minus 2, that is here, and a bar minus b bar, that is 1, minus 4, 2. Right? This is the simple determinant which we have already discussed how to expand the determinant in the matrix side. So now it is quite easy to determine the determinant of these 3 cross 3. So here I am directly put this one will be minus 4i minus 8j minus 14k. So this is, check yourself, minus 4i minus 8j minus 14k. So after all, in the end we will get that a bar plus b bar cross a bar minus b bar, that is equal to minus 4i, that is for minus 4, minus 8j, that is for minus 8, and plus minus 14k, that is for minus 14. So now we need to find the modulus of this one. So modulus of a bar plus b bar cross a bar minus b bar is equal to in root 16 minus 4 square, this is 64, minus 8 square plus 196, the square of 14. So this one is equal to 276 in root this is equal to 69 into 4, 69 into 4, so that is 2 root 69. Right? This is the answer of modulus of a bar plus b bar cross a bar minus b bar. So this is the second one. Now if we move to the third one, then third question is, if x bar is equal to 1 minus 2 minus 3 and y bar is equal to 2p and 4, then for what value of p, x bar and y bar are perpendicular? We need to find the value of p for which these two matrices are these two vectors are perpendicular to each other. First of all, we know that if x bar and y bar are perpendicular, then x bar dot y bar is equal to 0. So if we take x bar dot y bar is equal to 0, then I will get 1 minus 2 minus 3 dot 2p4 is equal to 0, because we need to find p if these two vectors are perpendicular, right? So if these two vectors are perpendicular, then dot product of these vectors is equal to 0. So by simplifying, we know that how to do the dot product. 1 into 2, that is 2, plus minus 2 into p, that is minus 2p, and minus 3 into 4, that is minus 12, is equal to 0. So by simplifying this one, I will get 2p is equal to minus 10, right? 2p is equal to minus 10. So p is equal to minus 5. So for p is equal to minus 5, these two vectors are perpendicular to each other. So this is the solution of third question of question number 5a. Now we have not more time to solve all three remaining questions of question 5b, but let us try to solve one of them, question number 5b. The first question is, so that the angle between vectors, let us first vector, that is x bar, that is I plus 2j, and y bar, that is I plus j plus 3k. We need to prove that the angle between these two vectors, that is theta, is equal to sine inverse in root 46 upon 55, right? This what we need to prove. We know that sine theta is equal to modulus of x bar cross y bar upon mod of x mod of y, right? In this way we can find the value of sine theta. So here x bar cross y bar, that is equal to I j k 1 2 0 1 1 3. So you can find the x bar cross y bar, and from here you can also find the modulus of x bar cross y bar. So from here I will directly write down that what the value of x bar cross y bar, that is this one is equal to 6 minus 3 minus 1, and modulus of x bar cross y bar, that is equal to in root 36 plus 9 plus 1, that is equal to root 46, and for x bar